Hello and welcome to our session where we're going to do an example by hand on topic number 4. So number 4 comes in 3 parts, so I'll call this 4.1, and we're doing the hand example, so I call that part B, where we do examples, and this is the first one, if that makes sense. But if you've been watching everything in the correct sequence, then it hopefully should. So what we're going to look at is our main book that I really love, Statistics for Psychology, and we're going to go to page 104, like so. So I have to scroll around looking for number 14. See if I can make this a little bigger even. I think I can. So number 14 there. Let's just write that down. So we're going to be on page 104. Fix my A there. 14. And I'll do I'm not going to do all of them. I'll do A and D. Let's read this first. On a standard measure of hearing ability, the mean is 300 and the standard deviation is 20. Let me just move this a little bit to the side so you can see it like that. Give the z-scores for persons who score a variety of scores, and then give the raw scores for persons whose z-scores on this test are like so. So let's do the first one for sure. So I have my mean and standard deviation, 320, and then if let's say my score is, I just saw it, 340, then my corresponding z-score will be the raw score minus the mean over the standard deviation, and let's calculate that. It should show up here on the right, but I'm always a little suspicious with my Discord insert not doing what I want. And we divide by 20 and we get a 2. Let's do part D. So these are pretty straightforward, so I'm not going to do all of them. You're welcome to, of course, practice as you need to, if you need to practice more. Give the raw score for persons whose z-scores on the test are, let's say, 2.4. So then we just flip the formula around. Now we're given here the raw score was given. Now the z-score of 2.4 is given. And if you remember the formula, let's put it over here. Z-score is x minus the mean over the standard deviation. If you then rewrite that to solve for x, we get x is the mean plus the z-score times the standard deviation. So that's what we're going to use. Mean is 300 plus 2.4 times my standard deviation of 20. Let's put that in the calculator and see what we get. My calculator's here on the side, but it'll pop up after I type it. I just need to, so I'm calculating 300 plus 2.4 times 20, and we get 348 using these formulas. Now I just remember the first one, and then you can swap things around using basic algebra to find the other one. So that's a good first question. The next one, continuing on this page, I want to do number 16. Let's move it to the top, like so. I think it doesn't go on 17. It's at the next page, so we can see all of it on one. So I want to move up here to 16. Just giving us a taste for what we should be able to do and doing it by hand like you may do in a written test. Let's read 16. The amount of time it takes to recover physiologically from a certain kind of sudden noise is found to be normally distributed with a mean of 80 seconds and a standard deviation of 10. Using the 50, 34, 14% figures, so sort of our rule of thumb for the areas under the normal distribution curve, approximately what percentage of scores in terms of this variable will be above 100, below 100, and so on and so on. So let's do a couple of these. I'm going to do them with our rough estimates, and just for the sake of practice, I know the question doesn't ask for that specifically, I'm also going to do it as exact as we can using our specific tables. So let's just remind ourselves here, the mean is 80, standard deviation is 10. And remember what this 50, 34, 14 rule means. If we have a little sketch here of the normal distribution, little bell curve, try to not be too wobbly here. We have the center there, but so that's at our 0 z-score, and then going to a z-score of 1 and 2. These areas are 34% and 14%. Those are the main ones I remember, and because of symmetry, then we can always double that for the other side, like so. So that's roughly what I'm thinking of for this question. So we have a score of 100. I need to convert that for A. I need to convert that to the corresponding z-score, same as before, 100. Raw score minus the mean over the standard deviation. Now this is simple enough. We could do by hand. 100 minus 80 is 20. Divided by 10 is 2. So we're sitting over here. And it's asking me what percentage of scores will be above this, whether I look at the raw score or the corresponding z-score. It's the same position. It's over here. So I can then look at the whole area all the way up to that line here, which only excludes this little bit. Now, knowing that this is, each half is 50%, these two together will be 48%. This little area over here, which I'll temporarily cover, is therefore roughly 2%. So if I want to do my rough approximation, which the question asks, it'll be roughly 2% sit above this score. But if I wanted to, just for practice sake, use my tables to find exactly what percentage sit above the score, I can go to my table and I'm looking for a z-score of 2. Let's go over here. I have it open. And I'm going to look at the second of the two columns because that's the tail, the little right side that I'm looking for above a specific z-score. I'm looking for 2, so I'm going to have to go way down to a z-score of 2. I'm getting closer. Here we go. I'll move it down so we can see the pictures as well. Z-score of 2, 2.28% in the tail. So roughly, we were very close. but to be more precise, it is 2.28. So I'm only doing this for the extra practice if you might need it, and a question could certainly ask that. So I'm getting as much as I can out of these questions while we're here. So number B, let's do B as well. B asks below 100. So above 100, below 100. Regardless, I have the same z-score because I have the same raw score. So again, it's 2. Now I'm looking for below this raw score. My z's look exactly the same as a 2, so let's make them a little different. So roughly, I can do it all from scratch, or I can look at this and say it's the same line here. If 2% is above, then 98% should be below. I can take this exact amount for the exactly. If 2.28% is in the tail, then 100% minus the 2.28%, which will be 97.72%, will sit on the left of that line. So I can always look at the side that is the most convenient for me, that fits with my tables. They don't do it necessarily exactly the way I want. Looking at the tail might be more convenient, even though the question asks for the other side. Okay, so that's useful to keep in mind. You can always look at the side that you prefer. Let's look at, I want to move this. Let's look at C and D just for extra practice. So my mean was 80, standard deviation is 10, C and D. So I'm looking at above 90 and below 90. So for C, for a raw score of 90, I have to calculate those, not equal. Calculate the corresponding z-score using the mean and the standard deviation. And then we get 90 minus 80 is 10 over 10 is 1. So I check my audio to make sure I'm recording correctly. I'm always a little paranoid, just in case. It's good to glance over. So now I'm first looking above this z-score. Now, if it helps you, draw this again. Good practice. So you sort of automatically memorize it. That's my z0 line. Let's say 1 is over there and 2 is over there. This is roughly 34%. This area is roughly 14%. And then the tail there would roughly be 2%. Not exact, roughly. So I'll do both for practice. So using this rule of thumb, above the 1 line will be the 14 and the 2 for 16%. If I wanted to be exact, which moving on into the upcoming topics, I certainly would want to be, I'm looking for the tail to the right of the z-score of 1. So let's go to the table. Looking for this tail, but I'm looking for a z-score of 1. So it's way down here, 15.87. Remember, that's the column I'm looking at. 15.87%. And you saw that, or you see that we were pretty close. So if I look something up in the table, I should have a sense of, does this sound like roughly what it should be? I don't know exactly, but it's good to have a sense for what these percentages are, given common, easy z-scores. Then part D just asks for below 90%. Well, if I have above, then below should be, hopefully, quite straightforward, same z-score. So if roughly 16% sit above 1, then just 100 minus that, so 84% will sit below. If I want to be exact, I can still follow the same logic, just using the exact score. I'll write that down here, taking it away from 100, because I'm now looking at the left side. That'll be 84.13%. All right, so just extra practice for this very important question. Let me just see if I have space here. I don't have a ton of space. Let me create a new page because I want to do number 17 as well. Oopsie, no, I want to move the page. There we go. Let's look at 17. Move up a little bit and to the side because it's on the next page. Don't highlight. My hand doesn't want to move it. I just want to move and slide it to the side so I can see those last words. There we go. Perfect. 17. We'll do a couple of these. Using the information in problem 16, so I still have the mean of 80 and the standard deviation of 10, using this 50, 34, 14% figures. What is the longest time to recover that a person can take and still be in the bottom different percentages? Let's do 2%. So now it's just flipping it around. What is the raw score that would put me in the bottom 2%? So let's say here, number 17, I'm doing A. Perhaps I want to visualize this again. It's not something I have to do in my head. Picture the bell curve here. 0. Let's put 1 over there and 2. And -1 and -2. Make this a little bit more solid here. So I'm looking for the bottom 2%. Now, whether it's the right or the left, I know that this area is 34%. This area is 14% roughly. And this area is 2% roughly. And this tail will then be the bottom 2%. So the cutoff separating the bottom 2% from the rest, roughly first, which is really only all the question wants, but we'll do extra because we want to cover that possibility. So it's roughly going to be at a -2 z-score. Then I want to find what is the corresponding raw score, same as up here, where we can flip back and forth depending on which one we want to do. Now we have the z-score, we want to calculate the raw score, so we'll use this guy over there. And we'll go mean was 80 plus the z-score times standard deviation of 10. Now these are very simple numbers, so we can just do it in our head. 80 minus 20 will be, I'll put it over here, 60. So that position will correspond to a 60. What if we wanted to do this exactly? Well, exactly, the 2% cutoff will not be at a z-score of -2 exactly. Let's go see what it is. Now remember, whether I look at 2% on the left, there's complete symmetry to the right side, and that's why the table only gives me one side of a tail. So I'm still interested in the tail. I'm interested in 2% being in the tail. So I have to go all the way down here. So 7% in the tail, 3% in the tail. Now, unfortunately, this is not going to be exact, but I'm over here at 2.02, and my other option in the table is 1.97. Now, you can argue different approaches here. There exists more detailed tables. They just don't want to give me that many pages. So often what we do in this case, we just average these two because the cutoff sits somewhere between 2.05 and 2.06. So we can average those out and say it'll be close to 2.055. So I'll say here exactly negative, of course, we're on the left, 2.055. Some people prefer to take, it depends on the question, what my goal is, take the more conservative one to the little bit to the left, which would be the negative 2.06. But this isn't an exact study where it's millions of dollars in the balance and life and death. Then we have no inaccuracy, and we know all the gaps in between these. This is just sort of a summary of the actual detailed table. So we take this rule of thumb of just going in the middle. I still want to find the corresponding raw score, and now it'll use this z-score in that same formula. Now this one I'll show on the calculator just so we have something to see. 80, I'll just do the minus right away, 2.055 times 10, but it's certainly something you could have done in your head, I know. And we get close to where we were, 59.45. Let's squeeze in one more. Why not? Let's do D. Let's see the question first. So now I want to know, still be in the bottom, 84%. Let's visualize this. Let's visualize this. It's always nice to visualize. So this is going to be, let's say, 1 and 2, -1, -2. I remember that this is 34% roughly. This is 14% roughly. And of course, this whole section over here is 50% roughly. Well, let me move this a little bit. Sorry. There we go. Like so. Hopefully nothing was cut off over here in case you need to see it again. I don't think we were working on the right here, but the CAD/CAM can certainly cut stuff off by accident. So I wanted to look at the bottom, 84%. 84%. So that's be 50 and another 34, putting me at this one line. That'll be the bottom. The left side will be 84% then. So roughly, that will have a cutoff z-score of 1. Then the corresponding raw score will be 80 plus that 1 times 10. Clearly that is 90. Which makes sense. It sits above the mean of 80 by 1 standard deviation step. If I want to be exact, and we'll end with this, now I have to look at the table and I can choose one of two. I can look at this section over here and that, oh, sorry, no, let me rephrase that. I'm looking for an 84% in the tail over here. 84. I know it's roughly over here. I want to find exactly what is the z-score. 84% on the left side will mean 16% on the right. So my preference is, yes, you can go 50 and then 34. I tend to just do the tail where I need to focus on the tail. There's no need really to flip back and forth with these tables. Most of the time the tail is the one I'm going with. So I'm looking for a 16% in the tail, and it's also the right tail as well. So again, we're not going to be perfect here in our summarized table. We don't see everything in between. We only go to 2 decimal places. So it's somewhere in the middle. So I'm going to average those two and say it's at 0.995. But I realize it's not exactly 995. We'll see once we have software that we can always be perfectly exact to however many decimals we want. I then find the corresponding z-score, the corresponding raw score, by plugging the z-score into my formula. Let's see, I know we could do it in our heads, but let's just have something to see on the calculator. 80 plus 0.995 times 10. So yes, it's exact to 2 decimal places, I guess. Not perfect at all, but because our table is still a little limited, we see we were very close with our rough approximation. So this first part of 3 in topic 4 is aimed at getting me used to the normal distribution, the bell curve, z-scores versus raw scores, and how I can use them, what the table tells me in terms of how to read it, the percentages under the normal curve in different sections, all that sort of number sense for this distribution is very important. And then we'll continue with more examples as we progress through the topics. But we'll stop here for now. Until next time.